Again audio check. Participants kindly check the audio is clear to you. Anybody can confirm that? Very simple sir. உங்களுக்கு கிளியரா இருக்கா? சார் ஒன் செகண்ட் ஆடியோ செக் பண்ணிங்க சார்.
Audible, sir.
Okay, ma'am. Participants kindly check once again. The audio is clear to you. Someone messaged that audio is not clear. Please check. Very sir, your side is okay.
Okay, sir. Fine.
Fine, sir. Fine, sir. It's working clearly. Very simple, sir. You can share your screen. Sir, screen is visible now. Professor, can we start? Are you ready, sir?
Sir, yes, sir. Sir, yes, sir. Sir, yes, sir.
Okay. Shall we start? I am very happy to welcome you all for the third day of the FTP on emerging innovations in chemistry and chemical technology. I welcome our resource person of today's session, Dr. P. Periyasamy, Assistant Professor, Selection Grade, Department of Physics, Nehru Institute of Engineering and Technology, Coimbatore. I extend my hearty welcome to all participants from various institutions in this forum and YouTube channel also. I invite Mrs. T. Parimala, Assistant Professor, Department of Chemistry, Arasu Engineering College, to introduce our resource person. Thank you.
Very good morning to all. It's my great honor to introduce the resource person of the day, Dr. P. Periyasamy, Assistant Professor, Department of Physics, Nehru Institute of Engineering and Technology, Coimbatore. Our resource person has completed MPhil at Christy University and he obtained PhD from Anna University, Chennai. Our chief guest is having 12 years of teaching experience. He has published more than 11 research articles in national and international journals. And he has published 11 books and 1 research patent. He has attended more than 15 FTP workshops and conferences, including national and international. He received research grant amount about 25,000 through various schemes. He has submitted more number of project proposals to various funding agencies such as CSIR, UGC, DST, ICSSR, CMRG, SCRP. It's our honor for having such a wonderful personality as a resource person in today FTP. Thank you for the opportunity given to me. Thank you.
Thank you, ma'am.
Thank you, madam.
Thank you, ma'am. I welcome our resource person to present the session. Thank you, sir. Please welcome, sir.
Yeah, sure, sir, sure. I think my PPT is visible to you all.
Yes, sir.
Okay, fine. Good morning to all. So myself, as told you, Dr. Periyasamy, I am working in namesake technology. Today I am going to deliver a topic on synergetic horizon on futuristic graphene for energy harvesting, water treatment technology and nanobio technology. This is my today topic. So I'm going to discuss with you these topics. So let me start our session by the introduction of graphene materials. So as we know that graphene is it is a single atomic scale honeycomb lattice which is made up of carbon atoms. So here you can see the structure of it, and generally it is a flat sheet of carbon atom where all the carbon atoms, each and every carbon atoms has a close association with a nearby 3 carbon atoms via the covalent bondings. And generally it is described as 1 atom thick layers of graphite. And so this is the basic structural element. So in this figure I have said this is the basic structural element of all other allostrophies, including it may be graphite, charcoal, carbon nanotubes and fluorines. And this is one of the strongest and the thinnest material ever we know that which is existing so far. And this is the geographical picture of graphene, and here you can see how the atoms are arranged. So each and every carbon atom, it is arranged in sp2 hybridized, and it is bound to its 3 neighbors. So that you can see in these pictures. So each and every carbon atom, it has a relationship with the nearby 3 carbon atoms with the covalent bond. And next, we will move to the history. So each and every material, each and every topic, there will be some history. There will be some peoples will be there who contributed, who dedicated their life. So likewise, here we have three peoples, and in the early stage, the concept of graphene was simply theoretically available, and it was theorized by Canadian physicist Phillips R. Wallis. So that is the first person who is standing in first person. And the theoretical concept, it was kept for a long time, that is before 20th century, and with some limited experimental works. And after 20th century only, it was interested. It was showed many people interest with the help of the advancements in material science. And one patent registered in USA in 2002, the name of nanoscaled graphene plates. So this is the first patent is registered on graphene for the production of graphene. And after 2 years, two fellows, Andrews James and Novus Bloch at the University of Manchester, they extracted the single atom thick crystallites from bulk crystallites by the method of Scotch tape method. So these two fellows, they received many many awards for their work, and the main award is Nobel Prize. They was these two fellows were awarded Nobel Prize in 2010 for the invention of single atomic thick crystallites from the graphene materials with the help of Scotch tape. So let us move to its structure. So here I have shown the different structures of graphene. And as I told you, this is a two-dimensional network of graphene atom. So these all atoms are arranged in a honeycomb array composed of 6 membered rings. So right side you can see the ring. So each and every ring, it consisting of 6 carbon atoms, which are all having the close relationship with each other. And by stacking all these layers, we can form a three-dimensional graphite crystal for our requirement, also for our research. And if you are wrapping it, you can make it is a zero-dimensional fullerenes. And if you roll it, it becomes a one-dimensional nanotubes. And if you are stacking it 1/1, we will get there. So that is the meaning for graphene. And so here you can see the images of all the different forms of graphene. So zero dimension, this is the example, the zero dimension is fullerene. This is the form. And the second one dimensional carbon nanotubes, and a plate shape. So this is a two-dimensional graphene. And 3D, if you are arranging these 2D 1/1, finally we will get a 3D graphene. And we know diamond is the very hot, which is consisting of carbon. So the structure of carbon is given here. So this is the different forms of graphene available naturally. And now let us go for the detailed different forms of graphene. So here we have seven or eight different structures. And the first one is monolayer. Monolayer is nothing but it is the purest form of graphene, and which is consisting of single layer of carbon atom. So in left side, the first figure, you can see the pictures of monolayer graphene. So which is consisting of single layer of carbon atoms arranged on a hexagonal lattice. And second picture, it clearly shows that multi-layer graphene. So which is consisting of several layers of graphene stacked on the top of each other. So if you are arranging 1/1, we will get the multi-layer. And another form, third form is graphene oxide. So most of people we are using for our laboratory work, and also for manufacturing of some auto electronic device and also battery work. And so this is nothing but this is a chemically modified form of graphene. So here we have to adjust the oxygen containing functional groups. It may be epitoxyl, hydroxyl or carboxyls, but maybe that we have introduced with the graphene structure. So finally we will get the graphene oxides. So we have introduced the carbon containing functional groups. So we will get the carbon oxide. And the fourth one, reduced graphene oxide. So in third case, we introduce the graphene. In fourth case, we are going to remove some kind of oxygen. So by this way, we are getting the reduced carbon oxide. And here we are restoring its sp2 hybridization of carbon atoms So the first figure, it represents monolayer. The second figure represents a multi-layer, and third figure represents graphene oxide, and fourth figure is the reduced graphene oxides. Sir, am I audible to you all?
Yes, sir. Everything is fine. Please carry on. Everything is fine,
Okay,
sir.
sir, fine.
Clear. Please continue.
Yeah. Okay, sir. Okay. I thought I'm talking alone. Okay.
No, nothing, sir. Nothing, sir. You are listening.
So, fine. Okay, fine. And the next form is nano ribbon. So it is a narrow trim strips of graphene that with the width of 1 nanoscale. So in the left side, the first picture, it shows the graphene nano ribbons. And the second one is graphene quantum dots. So this is the very small, and also which is in the dimensions of nanometer sized piece of graphene. Okay, so here in quantum dots, as we know that it exhibiting the quantum confinement effect. Because of the quantum confinement effect, we can adjust the electronic and optical property. So thereby we can use these graphene quantum dots in almost all electronic materials, all electronic research works. And third one, sixth one is a three-dimensional graphene material. So here we have to assemble the nanoparticles or graphene nanoparticles or one layer. So by you stack 1/1, you will get three-dimensional. So here we are having different kinds of methods to develop these 3D structures, particularly from graphene. So finally we will get a graphene foam, aerosol, and sponge. And the next one is graphene nano plates. So these platelets are like graphene particles with a multiple layer. So the fourth figure shows the graphene nano platelets. And the fifth one, it shows the functionalistic graphene. So we can attach some kind of chemical groups for enhancing its chemical property or mechanical property or electrical property. Whatever things you want to enhance, we can attach some kind of chemical groups or molecules. So those are all called as the functionalistic graphene. And the last one is called a bilayer graphene. So here it consisting of 2 layers of graphene, which are all stacked 1/1. So by these are all the different forms of graphenes available that we have to use. We are using in different research works. And let us move. It's a chemical property. So one of the as a chemistry faculty or science faculty, we are very much fascinated about the chemical property. So what would be its chemical property? Its resistivity, it's the catalytic. So these things we are interested. So here I have given some peculiar chemical properties of graphene. So it is a most reactive form of carbon. So it is highly sensitive, and it is only form of carbon, and each single atom is exposed to chemical kinetic actions. Particularly the atoms which are all the carbon atom which are all at the edges of the graphene sheet, they all have a special attention. So they have a special chemical reactivity, and graphene it burns at low temperatures, particularly 350 degree. But some researchers they have conducted 550, 650, 750. Some people they have done the work at 1100 degrees Celsius. So that depends upon their requirement. They have done it, but at the temperature of 350 degree itself, it starts to burn. And this graphene can be modified in the presence of oxygen, nitrogen containing functional group. If you are allowing oxygen or nitrogen gas inside the chamber of graphene, and it can be modified its electronic and optical property, particularly its chemical property. And graphene, its derivatives, it exhibit catalytic activities. So because of its unique electronic structure and high surface area, since we have only one carbon atom and its dimensions are in 1 nanoscale, so that it have a very peculiar catalytic activity. That's why we are using in energy storage device, and also water treatment technology and nanotechnology, and many researchers they proved this catalytic property in the above mentioned 3 field. And as electronic properties, so as I told you, so this is a peculiar one, and which has a very high electrical conductivity. and simply we can see there is no resistivity. Okay, the resistivity is completely zero, and inside the graphene material, the electrons can flow from one end to another end easily than the copper. Right? We believe that copper is the very low resistive material, but here the high electrical conductivity is very high, so the electron can move from one end to another end very easily. And while moving through the graphene, the electrons may have the speed of just one hundredth of that speed of light. Just imagine how fast the electrons are moving from one end to another end. That's why nowadays we are having a battery with the help of graphene material. That's why we can charge it very quickly. And now we are having LED screens, some nanobit technology. They are using this graphene material to heal the wounds, which can deliver the energy very very fastly, rapidly. And here the mobility, the charge carrier mobility is too high. And I told you it is a zero resistivity, high electrical conductivity, so that the charge carrier mobility is too fast. It goes to 10,000 centimeters squared by watts, or in some cases it twice of its values. Okay, this is also reported. And its band gap can be tunable from 0.0 electron volt to 0.25 electron volt. So 0.25 electron volt is too small. So these two value can be tunable by the way of varying the preparation methods. By adjusting some parameter, we can able to tune the band gap of the semiconductors. Moreover, the electronic properties also we can modify by the way of varying its methods. We can modify its electronic property. So here I have mentioned electrostatic gating and chemical doping and strain engineering. So these are some methods where we can adjust the electronic properties of the graphenes. And here I have taken the semiconductor. Generally in semiconductor, all electrons are attached to some kind of some atoms. Suppose if an atom want to liberate from that or free from the atom, it needs some energy. It may be heat form or photon. Then only it jump from one end to another end. Because in semiconductor we have some kind of band gap, whereas in graphene the band gap is infinite small, very very narrow, so that the electron can move easily inside the easily and very fast manner within the graphene materials. So this is the best comparison for semiconductor and also graphene. We believe that semiconductors are the very low band gap material, but graphene which is the zero band gap. And another property is mechanical properties. So all the mechanical properties, scientists used atomic microscope to find its mechanical strength. So in right side I have placed one image on the our pencil. The elephant is standing on. That means the graphene can hold the 1 ton minimum 1 ton of one weight. That is its mechanical strength. And moreover, it is the very harder than diamond and about 300 times harder than steel. Okay, so obviously we know that diamond is very hot and graphene is very harder than diamond and also 300 times harder than steel. So just imagine how the elephant is standing on this graphene material. And it tensile strength, it goes to the 1 terapascals. That means it may execute gigabytes, terabytes. It goes to the maximum levels. And we can stretchable. We can stretch it to the 20% initial length. If you are applying the many mechanical force, mechanical stress on it, we can extend, we can stretch it. It will extend its limitation up to 20% of its initial length. And it has a high fracture toughness, which means that it can withstand the crack propagations. So it will not allow the crack to propagate through itself and resist the brittle fractures. That is the beauty of it. And if you are applying the mechanical force, what happened? It will deform, then it will regain its original shape. So that is its the fantastic thing associated with the graphene. So it can recover the original shape after deformations. And graphene's mechanical property can be anisotropic. That means they vary with the crystallographic orientations. So these are all the some mechanical properties. In right side, I have listed some values observed in the laboratory, and the Young's modulus, Poisson ratio, fraction, fracture strength. So these are all associated with the physical and also mechanical properties. Just to think how greater it is. And because of its peculiar mechanical property and also stretchable property, we can able to prepare a new generation of super strong composite material. That's why now we are having a cell phone or laptop which can be foldable, and now we are having the what do you call the solar films that can be rolled in a wall, or wherever you want we can roll it. So because of its mechanical properties, and also slightly associated with the optical properties and flexibilities. And the next two properties, thermal properties. Of course, it is a very strong in nature. It is a perfect thermal conductors. So here the thermal conductivity is very much higher than the carbon structures. Then here I have given it, which is greater than 5,000. Okay, so it is a very good thermal conductor as well as the electrical conductors. And the 3D graphene, it shows a thermal conductivity about 5 times smaller. The ballistic thermal conductance of the thermal is isotropic. That means if you are applying the thermal energy on graphite material, the temperature will be uniformly spread in all directions. So that is called the ballistic thermal conductance of the graphene. And the specific heat capacity of the graphene is relatively low. That means it can be heated up or cooled down quickly in response to the change in temperatures. So that's why the specific capacity of the graphene is relatively low. And another one, it exhibit a negative coefficient of thermal expansions. That means it contracts along its lattice vector when heated. While we are applying thermal energy, it starts to contract, and when we are removing the heat, when you're cooling down or removing the heat energy, it will come back to original shape due to its peculiar mechanical properties. And here I have given the one composite silicon diamond structure. So this schematic diagram shows a three-dimensional stacked chip with the layers of graphene acting as a heat spreaders. So if you apply the heat, it will spread the temperature in all dimensions uniformly. So that is the beauty of it. And another peculiar property is optical properties. So it is nearly transparent transparent from UV light to IR regions. And even though it is a transparency, it can absorb some light. It may be UV light or visible in the region of visible and UV regions. And due to its unique electronic property, it absorbs it absorbs 2.5 to 2.3% of light, which is passing through itself. So I initially told it is transparent. Even though it is transparent, it absorbs some energy. It is exhibits strong absorption of light. It absorption ratio is 2.3% of light, which is passing through itself. And graphene, it supports surface plasma resonance, and which are all collective oscillations of electrons. And this graphene exhibit strong non-linear optical effects. So because of the frequency where you can use the frequency conversion and ultra fast optical switchings. So in these places we can use this graphene material. So where we want to frequency conversion, and also where we need ultra fast optical switchings. So it's just like switchings. And broadband photo detections. It can detect the photo from the photo detections in the range of UV to for IRA wavelength. And under some certain conditions, it can emit light. So now some papers reported that with the help of graphene, we can prepare a LED, that is the organic LED. So that is also reported. So these are all possible because of the properties of photoluminescence and electroluminescence associated with the graphene materials. So these are all the optical properties. And now let us move to some of the applications. So initially we have discussed mechanical, optical, thermal property, electrical property, and optical properties. So collectively, all these properties are studied and we are using in industry. So particularly in electronics field and biological engineering and filtration, that is water treatment, and lightweight strong composite material, and also in nanotechnology for the bone replacement, teeth replacement, and in our wood healing also we are using this material, and photovoltaic and energy storage device, that is the energy harvesting and the conversion technique, we are using these graphene materials. And here I have given some one or two examples, biomedical example. And at presently there are some reports that graphene could be used to analyze DNA, and which is a record-breaking pass. So in USA, some physicists, they have identified a new way to read the sequence of chemical basis in DNA strand by sending a molecules. So they are in the process of studying the DNA. So artificially, they are in the stage of developing the DNA, and something they have achieved, and the full form is not yet released. And partially it was reported in journals and also patent. And the next application is ICs. So as we people are enjoying the modern electronic goods, so these are all possible because of the ICs. So here, because of the high carrier mobility and also low noise, we can use the graphene material for the manufacturing of field effect transistor. So that we are using in ICs. And a processor using 100 gigahertz transistor on 2 inches graphene sheet. So within 2 inches of graphene sheet, that means in 51 millimeter size of graphene sheet, we can place a processor of 100 gigahertz. And also graphene based IC handled the frequencies up to 10 gigahertz. So just to think about its value and also its worthy. And a transistor printed on a flexible plastic that operates at 25 gigahertz, and it is transmitting speed is a tera speed transmitter. So these are all the electronic development they have reported in the journals and also in patent. So IC plays the major role in the modern technology, and particularly in telecommunications and also in electronic components. And because of the electronic and optical properties, now we have come up with some new invention, that is graphene LED. Which we can call it as organic LED, and which is the transparent conducting electrode. So all the electrodes are transparent because of the transparent properties of LED. And moreover, it can stand some kind of force and stress because of the mechanical strength and flexibility. Okay, so that's why we are now we are step outside to the old one, and we are stepping to the graphene based LED because of its high strength and flexibility. And it would work even we are using in optoelectronic applications. That means a touchable touch screens, liquid crystal LED, LCDs, organic photovoltaic cells, which we can dispose and reusable purpose also. And we are using at present we are using organic light emitting diodes. So these are all possible because of the peculiar optical and electronic properties of graphene materials. So now we people enjoying the touch screen and also organic photovoltaic cells, and also the organic LED and LCD screens also we are all enjoying. So these are all possible because of the peculiar optical and electronic properties of graphene materials. And filters. So here you can see in this picture, in left side there is here we have filters only, but we don't have any kind of any graphene material. So but in right side we have here the green red color balls, which are all the graphene material. So which is 1000 times efficient than the ordinary filters. So that is the basic things. And in bottom side you can see some color pictures. the H2O and NaCl. So the nanoporous graphene. So when we are passing through, when we are using this nanoporous graphene as a filter, the most of the unwanted chemicals, substance we can be filtered. Okay, so that is the beauty of it. And technically we can say it is a desalination. And also in distillation. So this graphene oxide membranes, it allow water vapors to pass through it, but impermeable to the other liquids and the gases. That means this that much of tiny holes we have, it allows only liquid H2O molecules only. All other molecules are filtered. So it will revolutionizing the economics of biofuel production and also the alcoholic beverage industries across the world. So this filter also, the research on filter is also getting attention at presently with the help of the graphene decoration filters. And solar cell, obviously we are all very familiar with the solar cells. So across the world, several $1,000s of dollars we are investing in solar cell, and also we are getting investment outcome from the solar cells. And for the manufacturing of solar cell, the graphene is a candidate materials, and also the photoelectrochemical energy conversion. So there we can split the water, and there also we can use the graphene material for the energy productions. The transparent, conductive, and ultra-thin graphene films are fabricated from the polyester graphene oxide followed by thermal reductions. So these are all the highly efficient, and the obtained film exhibit high conductivity of 550 s by centimeter, and a transparency of more than 70% over 1000 to 3000 nanometer range. So these solar nowadays the solar cells are seems to be transparent and also more efficient. And in Australia and some education institute and also some blocks, they are using, and also roof, they are using the solar tape. So those tapes are transparent, and in some Australian company they have come up with the rooftop. The rooftop are prepared with the help of solar panel, and with the help of all the solar panels are prepared by the graphene material, and which is far more better, and which is producing high energy than the conventional ones. So next we have the energy storage devices, that is a supercapacitor and a lithium-ion batteries we know. Because of its high surface area of the graphene, we are using this graphene material in supercapacitors. So nearly some thousands of reports were available in 3 platforms, mainly in Science Direct and also American Economic Society, Springer. In all the 3 famous platforms, some thousands of reports available. Many people are investigated this material. Particularly, I am also investigated this topic, and this supercapacitor is gaining attention. But now we are having the supercapacitor device that we are using in electronic bike, and also electric car. Also we come up, and recently our Tamil Nadu government also announced the electric bus. So where they are using the supercapacitor and also lithium-ion batteries. So these energy storage devices are nowadays all the electrodes are replaced by the graphene material because of its high strength and the remarkable electronic properties, and the electrochemical integration is so fantastic one. So that this energy in the energy storage device sector, graphene it is becoming a core part. And the next one, the nanobio technology, that is antibacterial. As I told you, this graphene is one of the biomaterials. So we can use this graphene material as a antibacterial applications, and we people are started to use in cancer treatment, the tumor treatment, and the wound healing. What you call the water treatment technology we are using. Some kind of bacteria, fungus that can be filtered, that can be destroyed with the help of the graphene. So it is getting more attention at presently, the anti-battery field. And some other applications, so nanoribbons, IR detectors, and single molecule gas reductions. So that is the gas sensor, and the piezoelectric materials where we can produce the electric charge, where we are having the vibrations, and energy harvesting, composite material. Composite material, we are the composite material decorated by the graphene material. At presently, we are using in body, in physical body, to strengthen the bone, to give a strength to the bone, to heal the fracture, and to support layer to the flesh. So now we started to use it. And a liquid cells for electron microscopy. So obviously, as a material science researcher, we people are most frequently using the electron microscopy. There also we are using this graphene material for liquid cells and thermal management materials. So this is one of the major problem in thermal industry, and also in energy storage devices, because it while we are using our electronic gadgets for a long time, it gets warm up, it gets heated. So the heat must be dissipated. The electronic material should be withstand the temperature range, so that they optimize something, but still they are working on it. The thermal optimization of graphene materials and optical modulators, what you called what I told you in previous slides. That is a touch screen, LED, optical turn devices. So there we are using this graphene material for our betterment of life, and also in chemical sensors. So to sense these chemicals, and also the remove the to identify the chemicals, hazardous chemicals. It may be drinking water, or whatever it may be. We are using the graphene material in these sectors. So these are the some of the applications where many people are doing some kind of research. So now I completed my one part of my talk. Now I'm entering into the next one. That is my own talk. That is the energy storage devices, and also water treatment technology and nanobate technology. And so there's a single material. It is dominating, and also it introduce lot of revolutions in IT field, and also in solar panel, and in communication, and in cell phone, and also in electronic field. In all this five sector, the graphene, it is going to it started the revolution, but it is still each and every year, some scientific company from USA and also in Australia, they are come up with a new property, the new invention with the graphene materials. So it is one of the wonderful material which is revolutioning in the world in all the sectors. So the first one is the synergetic horizon on futuristic graphene for energy harvesting applications. So generally, energy harvesting and storage is a broad theme. So here we have many techniques: the mechanical energy storage, and the chemical energy storage, biological energy storage, magnetic energy storage, thermal energy storage, and thermochemical energy storage. And recently now they have come up with a new kind of another some energy storage devices. The technology, that is hydro storage, electrochemical batteries, and compressed air storage. This sodium ion batteries, and organic molecular storage, and flywheels. So this is old one. And latent heat storage. These are all the some other energy storage systems that we are using it. And in this field, we started to use the graphene material because of its unique properties of electrical, mechanical, thermal, and optical properties. So these four properties make this material as a candidate material for energy harvesting, and also in storing and conversions. And here we have two kinds of methods: top-down approaches and bottom-up approaches. In all methods, we can use this graphene material in supercapacitor, hydrogen production, also battery, fuel cell, and solar cells. So in this energy storage field, the metal oxides, Nowadays we started to give up of metal oxides, and now we started to use the graphene material, and also what do you call the activated carbon materials, because of its environmental friendly. So as far as concerned, let us go to the supercapacitor, which is dominating, which is fascinating the young minds. So that's why I have taken this topic, graphene for supercapacitors. So what do you mean supercapacitor? That I have given a few glimpses. So supercapacitors are the energy storage devices which bridge the gap between traditional capacitors and batteries. Traditionally we had some capacitors and battery, and which has some flaws. So those flaws within the battery and capacitors are recovered, are removed and overcome in the supercapacitors. And these supercapacitors offer high power density and a rapid charge discharge capabilities and long cycle life. And in our cell phone, in our electric bikes, or it may be electric motor or electric bus, whatever it may be, uh, we need high power density. The charge discharge ratio should be very high. The battery should charge very rapidly. It should slowly discharge. So, and also we got to do the process long time. So for this, these works are very remarkable things in supercapacitor. And graphene's unique properties make it ideal candidate for supercapacitor applications because of its peculiar mechanical property. So because of its high stiffness and tension strength and prevention of fracture, while there's ion intercalations, it will not rupture and it will not decompose it at easily. So that is the peculiar mechanical property supporting here. And also because of the high electrical conductivity, high mobility, the ions can be interchanged from one end to another end between the two electrodes. Okay, so that's why this graphene material, it is a candidate material for supercapacitor applications and also research. And here I have listed some of the key parameters. Because of this only, graphene is a candidate material for supercapacitor. The first point is high surface area. So for ion intercalation, we need a high surface area. So that first criteria is fulfilled by the graphene material. So it is easy to it provide a lot of space for ions to absorption and desorption during the charge and discharge. And the second important point is excellent electrical conductivity. As I told you, graphene, it has a zero resistivity and a high electrical conductivity. So there is no, simply we can say there is no, and better way we can say reduced internal resistance, and enabling rapid charging and slow dischargings. So because of the problem, this is second criteria, because of the we are using. And low mass density. So this is particularly important in portable and mobile applications where weight is important. So in mobile, the mobile battery or laptop battery, or wherever we are having a handy electronic gates, we are having a battery. So in that battery, we are using a small volume material. So within the small volume, we are using a small volume, maybe a few gram of graphene, that is sufficient to provide the excellent electrical conductivity and also excellent high surface area. So this is the third eligibility and third criteria. And fourth one is mechanical strength and flexibility. This graphene can withstand mechanical stress while the charges are charging and discharging. And this cycling process will go repeatedly. The temperature may vary ups and down. So in those cases, it will not deviate. The mechanical strength will not be given. That's why this candidate metal for supercapacitor. And chemical stability. So it is highly resistive to corrosion, so that we can use it for long cycles. Okay, and the another one is tunable pore structure. The pore structure of the graphene can be adjustable. It can be tuned by the way of tailoring some of the methods or we can add some other chemical functional group associated with that, so that we can tune the pore structures. Here in supercapacitor, ion intercalation is important. For ion intercalation, electrochemical ion intercalation, pore structure also important. So that in supercapacitor is a flexible one, so that we can adjust the pore structures and functionalization. So this graphene material can be easily functionalized with some other chemicals for enhancing its compatibility, and also its improving its mechanical and
Sir, your audio is disconnected. Please check. It was interrupted. Audio start receiving. No, sir. We are not here. Just now it's disconnected.
my mic is muted. That's why I asked you.
It's okay, right.
Okay, no issues. Okay, fine. And the last one is environmental sustainability. So this is one of the biomaterials, so that it will not harmful to the environment. So because of that only, graphene is a candidate material for supercapacitor and also the battery field. And here I have taken some examples reported by some researchers. So the paper title is given here. The reported paper title is given here, and whatever they have achieved, that is given in the pictures. Okay, so here the graphene-based composite films are prepared with cooperating graphene oxide with the high conductive graphene flakes. So here you can see graphene flakes. So with this combined effect, so it will which exhibiting the high electrical conductivity, and it provide the extra pseudo capacitance. So that in this report they have reported the 91.1 farad by gram the specific capacitance, and you might think that it is low, but this is also sufficient for preparing low volt supercapacitors. And these supercapacitors are highly flexible, and we can bend it. So in top side you can see the flexible supercapacitors, which is prepared by the porous graphene composite films. So its conductivity becomes 214.7, and its specific capacitance 6.6, and a rate capacitance 31.5, and its strain and the tensile strength, it is 2.29.4, which is a very good one. And while we are using its reduced graphene oxide, we are getting the one of the very good flexible electrode material. We can use this electrode material for preparing flexible supercapacitor. So this electrode can be bendable, stretchables, and we can use it in where we are having a different shape of electronic gate kits. So my second report is the fuel coke derived from the nitrogen and phosphorus doped porous graphene structures for high performance supercapacitors. So here they have prepared the graphene material from the coke, and they deposited they doped with the nitrogen and so phosphorus with that, so that its chemical and mechanical properties are enhanced. So that, and they achieved the high specific capacitance of 323 Hg. Okay, at the 1 Hg, and almost 11 times greater than the undoped coke based graphene derivatives. This coke means carbon based graphene derivatives. So this is also one of the remarkable reported there. And they also prepared the a flexible supercapacitor device. And self-assembly, many graphene acid composite material, which is prepared by the laser-induced graphene method. So here also they achieved the flexible material, and all those patterns are programmable patterns. So simply you code it, you scan it, you will get the informations, those things. And this LIC, this laser-induced graphene-based supercapacitor, it showed the specific capacity retentions of 98.9% after 6 months. So that's why I have taken this topic. After 6 months, the capacity was returned to maximum level, that is more than 90%. That is and after 1000 cycle charge discharge process, the columnic efficiency is 102 percentage. So which is a very good report for supercapacitor. This is all possible because of the graphenes were prepared by laser-induced methods. The corresponding attributes given here. Those interested, you can. I will share the PPT to coordinator. You can get it there, and you can go through this paper. This is also one of the remarkable reported on graphene material for supercapacitor applications. And next we move to the solar cell. So across the world, many industry, many startup company, they have come up with solar cell idea, and many country they establish solar panels in their remote areas and also wasteland also. So it is highly graphene materials are highly suitable for solar cell because of its unique combination of electronic, optical, and mechanical properties. Electronic property means high conductivity and high mobility. Optical properties means it is transparent, and the charge carriers can be easily mobilized. Mechanical properties means it can be withstand the with the high stress. So because of this electronic, optical, and mechanical properties, this material is a candidate material for solar cells. So the important properties are just listed here: high electrical conductivity, transparency, broadband light absorption, high carrier mobility, flexibility and durability, versatility in a device design. That is the main thing. And the thermal properties, while it is exposed for long sunshine, it may warm up. The temperature may be dissipated even instantly because of the thermal property. And the potential for tandem solar cells and tunable properties. So because of these properties only, the supercapacitors are highly suitable for solar cells application. And then how far supercapacitors are, and how far the graphene can improve the efficiency of solar cells. So the solar cells performance can be classified into three phenomena. In first phenomenon is enhancing light absorptions. So when light fall on the solar panel, the light should be absorbed. So for that, the first thing is broadband light absorptions. So as we know that graphene is exceptionally very good optical properties, so it can absorb the light as much as possible. It may be a wide range of range, from the range start from ultraviolet region to infrared regions, so that the solar cell with the graphene components to capture the broad spectrum of sunlight, and we can improve we can get the more solar energy from the sunshine, and multiple reflections. So because of its high electrical conductivity and also the suitable optical property, multiple internal reflections of light is possible, so that all the light absorbed will be reflected inside that. So the electron charge recombination and separation process will be started. So as the light reflects in multiple times, more photons will have an opportunity to interact with the absorbed material. So it enhances the photon absorption and also electron excitations. and anti-reflection coatings. So this graphene also uses anti-reflection coating. So once the sunlight is absorbed, it will not become it will not be re-emitted from the panel because of its anti-reflection property. We can minimize the reflection of instant light, so that we can ensure that a large fraction of sunlight enters the solar panel. We can avoid the loss of light absorption or sunlight. This is the first phenomenon, that is enhancing light absorption. So here the graphene is highly useful. And the second one is improving charge separation. Once the solar light enter into the solar panel, the charge carrier should be separated. So here, because of the high electron mobility and the external electrical conductivity, the charge carriers are separated, and all the separate charge carriers are given to the proper electrodes. Okay, so that we can avoid the loss of charge carrier separations and the heterojunctions. So it can be integrated with the other solar panel as a heterojunction material, so that it can interact with the semiconductor material, and it forms discordant junctions. It will help for these charge separations. So because of that, this junction allows the electron to move freely from the semiconductor to the graphene layer, and thereby it enhances the charge carrier separation and the collections of charge carrier in the right pole. So this is the second phenomena supported by the graphene material in the solar panel. And another one is charge carrier collections. Once the first phenomena is we have to observe the sunlight. Second one, based on with the help of the observed sunlight, we have to produce more number of charge carriers. So once charge carriers are generated, we have to collect it. So as we know that graphene is highly transparent, also highly conductive. So whatever how much energy charge carriers are generated, those all will be conducted to the right poles. So here we are using the traditional transparent conductive electrode material, but this graphene associated with the TCS, it can overcome some challenges, and it improve the efficiency of charge carrier collections without loss of any light. Ultimately, we are getting the high current output. And another point is the flexibility and the scalability. So we can manufacture the electrode materials in a flexible manner. As I told you, in Canada and also USA, they have come up with the solar cells in the form of rolling the film, and also the rooftop, so that we can install in a rooftop. It gives us a shadow, and also it will generate the charge carriers. So because of its flexibility and scalability, we are now preparing different kinds of electrode materials, which is highly adorable for us. And here I have given some potential applications of what do you call the graphene in solar panels. So in this report, they have reported that the efficiency of solar panel is increased to 24.15%, which is still underscores the advantage of the graphene-based approaches. And here they have used the intrinsic atmosphere amorphous silicon, that is A silicon heads, and P, that is P-type crystalline silicons. With the help of that, they prepared the solar panel, and they achieved the excellent efficiency. 24.15% is not a small one, it is a good one. And further optimizing the parameters of the electrodes material, it will be the optimal efficiency is increased to 31.2%, and the band gap is maintained at 1.6 electron volts. So this demonstrated that graphene-based electrodes for solar panel, it increase the solar cells efficiency, and we can obtain the more energy, and which is far better than the other solar panels. And another solar panel, graphene on metal, graphene associated with the metal grids as a transparent conductive metal for dye sensitive solar cells. So here they used the metal grids which is embedded on the graphene, so that it forms as a transparent conductive electrode. Metal grids are associated with the graphene, so that it becomes as a transparent conductive electrodes in dye sensitive solar cells. So here also the efficiency increased to 0.4% compared to the control group that is used by the platinum grids. So comparing to the platinum grid, which is very costly, this metal grid coated with the graphene is 0.4%, somewhat higher, and also it is a transparent conductive layer. So here you can see in the figure, you can see the electrode is highly transparent, counter electrode and electrolyte dyes. And the research also, they also conducted the research, stated that they achieved the efficiency of 0.25 from the 0.4 to the further optimization of the electrolytes and the preparation candidate design. They increase the efficiency to 0.25%. So this is also one of the peculiar and remarkable achievement in solar cell area. And let us come to my second target topic, that is water treatment. So water treatment is the challenging one at presently, because of the urbanization and civilization and industrialization, now we are getting lost of a lot of wastewater. So those wastewater becomes challenging to the municipal and also the living peoples for us also. So it contaminating the soil and the environment, and directly impact our human being life and also animals life also. So that many scientific peoples, many scientific group across the globe, they have come up with a new technique. They are now started to focusing on water treatment. It's not a new one, already they started, and many people they are working. But after the invention of graphene, after the incorporation of the graphene in this field, they have come up with a new revolutions. They have prepared a new kind of filters which is far more efficiency, and heavy metals also we can remove. The contaminated water can be filtered, reusable. Graphene, the enter of graphene into the water treatment technology is inevitable, and also it was welcomed by the scientists and so the public peoples. So here, the first thing is graphene oxide or reduced graphene oxide membranes. So these are fabricated into a membrane with a nanoscale porous. The graphene oxide and reduced graphene oxides are embedded into formed into the membrane at nanoscales. So these are highly efficient at the filtration, which can remove heavy contamination such as heavy metals, organic compounds, microorganisms from waters. And another way is these membranes. These membranes provides the nanoporous structures, so that these nanoporous structures allows the water molecules to pass through while blocking the large particles and impurities. So graphene oxide or reduced graphene oxide based membranes is a highly efficient. Membranes are highly efficient in water filtrations and adsorptions. So graphene and its derivatives are it has a exceptionally high surface area. Because of that, it can absorb the heavy metals or water pollutants or polluting the contents in the water bodies. So it will absorb the contaminants. It can be heavy metal, organic dyes or organic solvents, and so thereby we can reduce the bad things of the water. And functionalized graphene. So as I told you, graphene can be functionalized by some other chemical molecules or chemical compositions. So because of the functionalized graphene, we can design a new kind of membrane which is particularly targeted to a particular specific pollutants. So it depends upon industry. It depends upon the industry evolution and the outcome. We can develop a new kind of membrane with the help of functionalized graphene surfaces. So because of its high and also efficient absorption selectivities and desalinations. So it is a promising process in desalination process, because here water molecules pass through, while rejected salt ions. Water molecules only allowed, and the remaining water molecules are as remaining salts are filtered during their selective permeabilities. So the desalination, it is technique is old, but the graphene, after entering the graphene into this field, it becomes more efficient. So it has a high potential to address the water scarcity issues in region, and with limited access to the fresh water source. Wherever we are lacking of water, wherever we want to reuse the industrial water, there we can use this graphene oxide membranes for the desalination process. And in disinfections. So as I told you, graphene is the very good antibacterial material, and it shows the antimicrobial functions also. So the graphene coated materials or graphene coated filter, it kills the for some kind of fungus, bacteria, viruses. So we can use it in water treatment equipment. These coatings can inhibit the growth of bacteria inside the container, maybe microorganisms, and we can ensure the quality of fresh water at any time. And the graphene based photocatalyst, it can generate reactive oxygen species while we are exposing to the sunlight, and which can be used to the disinfection purpose. So the graphene can also be used for disinfection. That means remove the microorganism, bacteria, some kind of fungus, some kind of virus while it exposing to the sunlight, or because of its own nature of antimicrobial properties. So because of the property, we can use this graphene material as a the disinfection process in water treatment. And another method is removal of emerging contaminant. So these are all these graphene materials are effectively remove the emerging contaminants. It may be pharmaceutical residues, or pesticides, or personal care products, or wastewater from the wastewater. What may be the emerging contaminant. This can be easily filtered out with the help of the graphene materials. And also we can ensure the quality of water. And here also we can use the functionless graphene surface to identify the target specific emerging contaminant, and also we can ensure the fresh water and the energy efficient water treatment. So here the electrical conductivity of graphene is it is one of the peculiar one. That peculiar property can be utilized to improve the energy efficiency of water treatment process. So that include the electrochemical water purification methods. So graphene, it plays a major role in water treatment. We are using in different kinds. And here I have taken some examples. 3D porous alumina, graphene hybrids prepared by atomic layer deposition and their performance for water treatment. So here the gray color, it shows the graphene layers. So it is used to pure the waters. So atomic layer depositions are used to prepare this kind of this kind of filtration. And the hybrid material, the prepared with the 50% cycles of ALDs, atomic layer depositions, exhibiting the impressive surface area, 2,284 meters square by gram, and which is suitable for absorption of any contaminants. And because of its excellent absorption performance, with 80% and 90% removal of achievement is possible in first and second absorption steps. So while you are doing the first absorption, first process, you can achieve 18% of chemical reductions, and in second process, you can able to achieve the 90% of chemical reductions. And these hybrids also show the ability to reuse. These hybrids also we can use it as a reusable, and highlighting their potential for sustainable pollution remediation applications. So this is also one of the peculiar report reported on this in this water treatment technology. And another interesting thing is sustainable and decentralized water treatment system fabricated from domestic wastewater waste materials and ultra fast reduced graphene material. So here they used the solar power water purifier. So they used the solar power water purifier, and this system operates without the need of electricity during the water purification process, because it itself it produces the electricity, and which is a low cost and assembly technology. So this solar evaporation system fabricated easily and rapidly using a readily available material. It may be a waste paper and also graphene oxides. So we don't need technical experts in for manufacturing this kind of material, this kind of water treatment process, and even layman also can prepare design this material, this design. And here they are using the graphene cellulose aerogel. After using the this aerogel, it exhibit exceptional properties such as a high photothermal conversion, excellent hydrophilicity, and low thermal conductivity, and impressive performance material matrix. So this system is remarkable, and the evaporation rate of up to 1.83 kilogram meter square and covers per cover. And the photothermal efficiency is 93%. Moreover, it demonstrates stability over 40% operation cycles. So this is also one of the important and also attractive water treatment techniques with the help of the graphene for the water purifications. And another method is the novel combination of non-thermal plasma process and the heterogeneous nanocrystal nanocatalyst suburbs comprises zinc sulfide, graphene oxide, and polyaniline as an efficient strategy for the treatment of organic contaminated water. So here they use the DBT reactors, DBT reactor, and it is which is used to generate non-thermal atmospheric pressure organ plasma, and offering a versatile and efficient means of generating reactive species. And here also they are using some kind of material that is PNP photocatalyst, zinc sulfide, graphene oxide, polyaniline. So these are all used for synthesizing the reactor. So here the thermal efficiency is the water treatment efficiency is high. Here by the way of adding 5 gram of zinc GPG. So photocatalyst malachite green dye under a plasma radiation resulted in 90% of the contaminants were removed within 12 minutes. So just imagine how far it is a good one. So by the way of adding ZGP photocatalyst prepared by the graphene material, so it is more efficient at the range of 97% of waste removal within 12 minutes. So the another example is biopolymers. So at presently I am focusing on the water treatment technology, so that I have taken more example in this area, metal oxide and polymer, and some exams I have taken here. Okay, different things. So here they are using a biopolymers. So they are gadolinium ions. Gadolinium ions they are going to filter out. So gadolinium ions have a strong interaction with the anionic species, making them suitable for the removal of heavy metals such as arsenic. So they are using the polymer material to overcome the drawbacks of graphene gadolinium oxide composites, so that they can come up with a new achievement, that is the optimal after the optimal conditions for absorption were found to be operating pH of 4.0, the dose of 1.4 gram per liter, and temperature is 298 Kelvin. So the absorption capacities for chromium, lead, and arsenic were in the range of 29.16, 158.73, and 36.77 mg per gram respectively. So here in right side I have shown the pictures. So each and every components were filtered out with the help of this graphene materials. So the another one is bio-inspired. So biopolymer, that's one is bio-inspired. So by the way of adding biomaterial with the graphene, we can able to prepare a new nanofiltration membrane. So which is ultra fast water transport and selective for treatments. So here the graphene composites were synthesized by hydrothermal method. It resulted in a widening and well-defined two-dimensional channels. So here you can see the pictures. You can see it is a two-dimensional channels, and the water, the high water permeability, exceptionally water permeability, and with a rate of 107.4 liter meter squared kilogram per bar. So this permeability was nearly 4 times higher than that of the graphene membrane. So just a thing, while we are using this composite bio-inspired composite material as a water treatment, it becomes more efficient than the ordinary graphene membrane, and also excellent molecular saving ability. So it blocks the passage of molecules like methylene blue, carbonyl red, and rhodamine blue. So these can be filtered out easily, and hold promises for next generation nanofiltration membrane. So the nanofiltration membrane is one of the key factor in water treatment technology. So this can be prepared by either the nanopolymer or bio-inspired material, or some kind of metal oxides. And now we are moving to the last one, the last focused, that is the graphene for nanobit technology. So as we know that graphene is a single layer of a carbon atom arranged in two-dimensional honeycomb lattice. So why this graphene is most suitable for nanobit technology? Because this biocompatibility. So because of excellent biocompatibility, it can interact with the biological molecules. It won't harmful to our body. If it is inbuilt in our body, it may be bone, it may be flesh, or it may be in nerves, wherever may be, or over the nerve, over the bones. It will not harmful for our body because it is biocompatible. And drug delivery, because of the high electrical conductivity and easy fast mobility, we can use the technique for the drug delivery. So we can deliver the energy, we can deliver the medicines wherever we need, with reducing side effects. Okay, that is the main things associated with the graphene material in the nanobit technology. And the thermotics, and this is the real-time monitoring of the treatment efficiency, how the treatment is going on, how our body is reactive with the graphene material once it is inbuilt in the body. So these kind of real-time monitoring of treatment efficiency is possible. And tissue engineering. So graphene scaffold provide excellent platform for tissue engineering, and this with the help of that we can able to produce a bone, nerves, and cardiac tissues in regenerations. So I'll show you some report. And biosensing. So graphene-based biosensors are highly sensitive and selective. So they can easily detect various biomolecules. It may be DNA, protein, or glucose within a great precision. So this biosensing is highly needed and also highly necessitated in the biomedical field, in the medical field. So in that places, graphene-based biosensors are highly helpful. And cancer therapy. So graphene and reduced graphene have been explored for cancer therapy because of its fast drug delivery. Okay, in point number 2, we told you drug delivery. Because of that, we can use this graphene oxide and reduce graphene oxide for the treatment of cancer therapy. And neuroscience. So all it is used to do neural interfacing and recording of neural signals. So once it is embedded in the backbone or nerves or wherever the important systems associated in the body, it will interact with the nerves. So that we can able to get the information from our body. So our tool interact with the neuroscience, the nervous system in our body, so that we can get the information from our body without doing the further investigations. And wound healings. So graphene-based dressings can enhance wound healing. So they provide a protective layer, protective barrier, and maintain your moist environment and have the antimicrobial property, as I told you, and providing faster recovery. So it is advisable to have a graphene decorated wound healing or dressing tape with us if we have injuries and if anything happens, right? Because of its antibacterial property and moisturizing environment and faster moving charge carriers and bioimaging. So these graphene contour dots and graphene oxide have been used as contrast agent in various imaging techniques, including fluorescence and photoacoustic imaging. So whenever we are taking the bioimaging, it may be CT scan or MRI scan, there we are using this graphene material to find the exact position and place of our body, our target. And here also we have some biological barrier. So understanding interaction between the graphene and biological barrier such as blood-brain barrier is crucial for developing drug delivery systems and diagnostic for recovery conditions affecting these barriers. So as I told you, wound healing or wound healing or and drug delivery, cancer therapy, neuroscience, we are inbuilding the graphene material in our body. So it has some effect with the work, so that we are having some biological barriers. And toxicity and safety. The potential toxicity of graphene and graphene density is the subject of the ongoing research. At presently, I do submit a book proposal and a chapter proposal on this, the toxicity and safety of material. Even though this graphene is so good and so beneficial for our body, also for environment, also for science and technology, it has some kind of trouble with that. So that we need to ensure the medical safety before or after treatment. And here I have taken some examples how graphene and its composites are used as a biomaterial in stem cell differentiation. So stem cell we can obtain from the particular place, and we can develop and nurture, and after cultivating it, we can use it in all of it. Okay, so we can muscle cell and the fat cell, bone cell, blood cell, nervous cell, and the epithelial cell, immune cell, and the sex cells. Okay, so in all places we can use this graphene material, stem cell differentiation. Okay, so actually the stem cell differentiation means it is a process. Okay, it involving switching from the proliferation to specializations, and also this involves a succession of alteration in cell morphology, membrane potential, and metabolic activity and signal responsiveness. So after doing this process, stem cell differentiation, there will be some changes in morphology, membrane potential, and metabolic activity and signal responsiveness. So these are all possible, and many reports are available in the publication platform. So here also in all places, it may be lungs or heart or liver or intestinal or kidney or wherever we need, we can establish or we can process stem cell differentiation. So the first thing is it offers a precise control over the stem cell differentiation. The graphene, it offers a precise control over the stem cell differentiation, and they can be functionalized to provide specific chemical and physical glue. Okay, that will guide the stem cells toward the desired lineage. So it will do the just like the programming work. It will do it. Surface modification. So the surface properties of graphene can be tailored to promote or inhibiting adhesion, proliferation, and differentiation of stem cells. So this enables fine tuning of the different process and enhance cell adhesion and proliferation. So this enhances the large surface area and biocompatibility. These two enhances the cell adhesion and proliferation and creating a conductive microenvironment for differentiation and surface modification and drug delivery. So these are the pioneering points associated with the stem cell graphene based stem cell differentiation. So here I have taken the some examples. 2D graphene oxide particles induce unwanted loss in pluripotency and trigger yearly differentiation in human pluripotent stem cells. So we are treating this 2D graphene with the lungs. Okay. Potential makers and it prevent right. So this study from these articles they highlighted that the risk associated with the uptake and the accumulation of graphene in stem cell development, it leads to the unwanted loss of pluripotency and eager and yeah, yearly triggering of differentiations. So it will help to the reduce the harms in the lungs. So more report you can observe in the reference paper. And another one is smart graphene cellulose paper for 2D and 3D Vietnamese and origami of the inspired human stem cell supported differentiations. So we have to yeah.
It seems the signal is weak, I think. Your signal is weak. Sir, are you available? Sir, interrupt ஆயிடுச்சு திரும்ப உங்களை செஷனில் கூப்பிட்டு பார்த்தேன் ரிசீவ் ஆகலை நெட் இஷ்யூ இருக்கா இப்போ தான் ஜஸ்ட் 10 செகண்ட்ஸ் தான் கொஞ்சம் செக் பண்ணுங்க ப்ளீஸ்
Not audible.
So is it now visible to you?
The audio is okay, sir. Yes, you are more presenting. Yes, sir. Fine.
So now it is
Yes,
okay?
yes, it's visible now. It's fine.
Okay,
Okay.
okay, sir, fine.
Please continue, sir.
Okay, sir, fine. So this is some of the example how we can able to use the graphene for the stem cell differentiation. So how it is connected, and finally we are having the specialist differentiation cell which can use to cure the tuberous cells and cancer cell, blood cancers, water.
Sorry, sir. Sir, sorry. Sorry to you. It's again interrupted. Audio only interrupted. Mic, check your mic. No, sir. Your audio is disturbed.
So now it is okay?
Yeah, okay.
Okay, sir. Okay, fine. Okay, fine. So, so the graphene family nanomaterials in neural tissue engineering also, this is highly helpful, and so many people I have seen that the contribution of the researchers in India is limited, whereas in United States and Australia, many people are working in this field. I have found a little some very less number of papers only in this from India. So those people interested, you can come up in this field and can do a marvelous things. So this is my last one. Thank you all. So I will be happy to answer the queries.
Yes, Professor, thank you so much for your wonderful and highly informative session we are having today. We have plenty of information
Thank
for
you,
you.
sir.
This is the time to interact with our resource person about today's session. Resource persons can discuss with our guest. Please go through some other discussions.
So far I shared only some brief information. Whatever I did some research in supercapacitor, and recently I started my work in water technology, and I have a limited knowledge in nanobiotechnology. But some of my scholars and also my project student, I assigned this work the nanobiotechnology. So this field will helpful to you to achieve new things.
Yes, sir.
I will share this PPT to you, to your
Sir, good
coordinator.
afternoon, sir.
Yes, ma'am. Please,
Madam,
please
good afternoon.
carry
Tell
on,
me,
madam.
madam.
Good afternoon,
Yes,
sir. Sir,
Yes, madam.
you
Good
told a
afternoon.
lot of information and application of graphene is a different combination system, sir, for water treatment. Very nice information, sir.
Yes, madam.
Thank you. Sir, one doubt, sir.
Thank you.
Sir, please tell some experimental methodology to analyze the water treatment, sir. Water filtering capacity, like some methods, sir.
Madam,
How to find, how, yes, sir?
madam, that depends upon your material and also your process.
Oh,
That depends on, madam.
okay, sir.
See,
Yes,
there is
sir.
no standard. There is no
Yes,
we can prepare the graphene, but for water treatment we have to modify the procedure. Depends upon our aim and also our
okay.
project objective.
Okay, sir. So
I
gently
started.
absorption techniques only you.
But that depends upon our ultimate aim. What kind of water we are using, and what are the sediments we are going to remove. That based on that, we have to find the right seed material that we have to incorporate with the graphene.
Okay, sir.
We can. I could not give the exact solution because our aim is different, and material is so just like a clay. we can change to any pattern. We can fix it to anyone because of its excellent
Okay, sir. Okay.
mechanical, electrical, and optical property. We can adjust it to fit it to any property and any synthesis methods. At presently,
Okay,
what
sir.
I'm doing is I'm preparing the reduced graphene, and I am incorporating with some biopolymers and also bio-inspired method.
Okay.
So for water treatment, and it is in laboratory work only. After that only we can release the new idea, which we are
Okay, sir. Okay.
moving to the pattern work.
Okay, sir. Okay. Okay, sir. Okay. Thank you,
Thank
sir.
you. Thank you.
Any other questions, please? Okay, Professor, actually you shared about functionalization of graphene. Functionalization
Yes,
of
sir.
graphene, yeah.
Functionalization graphene.
You said a lot of information about the graphene and the functionalization also. So, is that any trouble or the structure will affect by the functionalization of our graphene? By, for example, acids or bases that will affect the structure of graphene.
Sir, as we know that graphene is a six-dimensional and which is a honeycomb structure based on the improved additions.
Yeah.
Slightly there will be changes, but there will not be not much more deviations
Okay, sir.
because it is a carbon material. No, we have carbon only. So what can it? Maybe you may add oxygen in the presence of oxygen or porous or heteroatoms. The best common example is heteroatoms. Whenever we are adding a heteroatoms, based on that, slightly it will be tuned. That we are expecting.
Okay, sir.
Based on that only, the porous size will be vary. If the porous size is vary, its intercalation process will be vary, and ion water in water treatment, what do you call the ion molecules filtration process also vary, and in nanobit technology, the drug delivery properties also vary.
Fine, sir. Thank you, sir. Anybody?
Thank you, sir. Thank you.
Anybody want to share their views? Okay, fine. Okay, fine. I would like to thank myself as a convener. Dr. P. Periyasamy shared a lot of information during his tight schedule, and all the participants also they were attended the session much interested. So thank you all. Now I invite our faculty, Dr. M. Vetrichilvan, Assistant Professor, Chemistry, Arasu Engineering College, to deliver the vote of thanks.
Very good afternoon, all. It gives me great pleasure for proposing vote of thanks for the FTP on the title of Synergistic Horizons of Futuristic Graphene for Energy Harvesting, Water Treatment and Nanobiotechnology. I render my heartfelt thanks on behalf of our management and our department to our research person for sharing his insights on graphene materials with us. I hope all the participants had a great and informative session. Thank you all.
Sir, thank you for the opportunity.
Yes, sir. Thank you very
Thank
much,
you.
sir. Thank you, Professor.
Yeah.
Thank you.
Yeah, thank you,
to
sir. Thank you
everyone.
very much.
Yes, sir. Fine.
Have a
Thank
nice
you
day,
to
all.
everyone. Now the feedback link will be shared in Google Meet and YouTube chat boxes. It will be available for 5 minutes. Please take your own time to fill up the feedback link. It will be available to you all. Thank you. Thank you for your patience once again.